Okay, next, team 3. We'll talk about cluster analysis. Shun Xiaowei and Lakaba will use about 30 minutes to explain the introduction of cluster analysis.
Hello everyone, and today our team 3 will talk about the cluster analysis, and we are mainly using this book, Data Mining and Analysis, and the first 3 chapters of the part 3 in this book. And here's I first show the reference, and this one is mainly we use. Means one book, means this book. And here's the outline. First, we will give the definition about cluster analysis, and next we will introduce some types of clusters. And as following, we will show some main types of clustering algorithms with examples. And next is a conclusion, and last part is the references. And here we're going to introduce what's a cluster analysis. Means easily here. Means here some data, and we just divided them into different groups. This is cluster analysis. Means very simple. Means for example, for students, yes, we can divide by key, no, by the age, or we can divide by girls or boys, like this way. But in our real life, maybe the data will be more complex. So which kind of technology we can use for cluster is we have to consider. And now we are going to introduce the types of clusters. First is very simply means well separated clusters. Means here there's those data, and here we can see they are very close together. And here, and each group there's big distance. So we can easily see we can well separated. And second one is about center-based cluster. Like a circle, here's the center, and there's many data in here, and also like this way. And also these two also, this and this one also are center-based clusters. And here is continuous clusters, like means with some special shapes. Here's given. Means here means density is very high, like this. And here means density-based clusters, and easily we can check. Means from the name easily we can understand. And here's conceptual clusters. Means there's some common properties, but also there's some special properties. And now we are going to introduce our mainly part of the means clustering algorithms. And already, actually, first 2 teams already introduced the k-means, but here also I will go more in detail for this part. First, what's the k-means clustering? So, actually, from this word we can easily understand. First, we choose k point as a center. Then we can find those states are very close to the centers. Then we can take k clusters. And again, for those data in the same clusters, we took the means. Then a new update centers will comes. Then again, we repeat it by this way until the center vertex did not change. Then we get the k-means clusters. So here is with another kind of explanation, means like mathematical symbols. Here, first t equal to 1 means original date, and first we choose this t point as the center. Then we going to repeat. When from here, if here means this is what we choose, date, center point, and this is the date from the original date. So if this distance is very small, very close, means we compare this value to all of this value. So which value is close? Then we took this I as G star. So this state will be going to the this state will be going to G star cluster. So that's why this comes to here. So repeat it by this way. Oh, and again, here's the update mu I, because already one new point comes. That's why that mu I will be changed. So here, actually we cannot always think that sometimes will be disconvergent. That's why here we just choose very smaller value to occur. If the change is very small, then we can stop. Otherwise, sometimes the data will be going to disk coverage. So for one small examples in the one dimensions. So first we can see the data. Here's 9 data. So first step 1 we choose just this one as the center and this one as a center. So and we assume so this point is 3.3 is close to. Actually, here is the same to this one and this one, but we assume this one belongs to this cluster. So these two in the one cluster, and remain because this point are more close to this point. So we are taking cluster here. So now we are going to next step. That means we have to in one cluster we have to get the new mean. New average means 2 plus 3 by 2, 2.5, right? Here also 4 plus 10 plus 11 plus 12 plus 20, 25, 30, and by 7. So we get 16. So now again we have to think this, for example, 10 is more close to this one or this one. From 10 to 2.5 is 7.5, but to here just 6. That's why 10 belongs to this cluster. So actually here, again, we get the new cluster, means 2, 3, 4 is in one cluster, and this part in one cluster. And the next, again, takes the average from this 3 data, means in same cluster. Then we get the average value 3. And here again 18. Then again we are going to get new cluster, update the cluster again. This value and this value again means repeated. Then we get finally 7 and 25. And if you repeat again, this value will be not changed. That's why we stop. And it means finally we find these 3 in one. This 6 in one cluster, and this 3 in one cluster. That's the main idea of the k-means clustering. And also for choosing the initial point is very important. Here is a different, when we start from different point, we get a different output. Means here we're taking the 3 means clustering. But finally the output is different because we're choosing start point different. So it's very important to choose the initial point. And here is one example I did by with R but in Sage. So I will show you here. Yeah. So here, like Team 2 introduced before, means we use R code. Here we use took the, as we know, here is a standard, not standard, but this is a normal distribution with mean is 0, and here mean is 1. So we randomly generate 100 point. 100 date, but we already know the mean should be 0, and here mean should be 1. So after cluster, that mean should be 1, here should be 0. It should be like that. So here, actually, what we did means finally, here is 0, almost 0, here almost 1. So this cluster, this way means we get a good, use the right concept to solve this problem. And if we try the, how about if we take 3 cluster, means here we take 2, but when we take 3, so some problems will be happen. Means here we can see which when we take 3, what's the mean is like x is 0.29, second one is 0.98, third one is 0.7. Like here's minus, here's yeah 3 centers. So
what if you try for
4 maybe also some problem. Here just we just change the value 4.
Then you will see the 4 centers.
Yeah, 4 centers here.
4 different colors.
Yeah, here's green, blue, black, red. Yeah, so like this.
So with the easy coding, then you can easily find the centers as much as you.
Yeah.
Mr. Chu, can you follow it? So that could be one of the easy ways to do so. Okay.
Yeah. Okay. Also, I also show the example
so you have
here.
The code there, so you can copy it. So for any data, you can use that algorithm on the web, and also you can download the Sage to practice it, or you can just learn the same code for the R program that you download as well. So, continue.
Yeah. Also, this example shows the importance of the choosing the number of the cluster. Means which key value, which value should be chosen is also big problems. And so what kind of data we can use the k-mean clustering? And so here we list out for those kind of data, it's difficult to use k-means. First is different size. If some cluster with different size, then it's not easy, because when we choose 3, because we know here 3, right? So we choose 3, but finally output is not like what we want to see. And also different densities. here, this 2 may be more, density is more high, but this is more lower. But when we do, and we know here should be 3 clusters, but when we take 3, then also some problems comes. And also non-globular shapes. Here we know this should be 1 cluster, this should be not 1 cluster, but the shapes not like the cycle. So for this case, when we take the 2 clusters, also some problems comes. It's not like the what we want to get. So how to overcome these limitations? One way to overcome is like this way. First, it's different size. So even we know just 3 clusters, but we can take more. Then it will be more, means we can consider this big one. So at least this 2 is separated. Yeah. So it should be more, or there's one way to solve this problem. And also for different density, also we can use more clusters, then we can get this output. And also for non-globular shapes, also we can do like this way. And next is about the hierarchical clustering. And if you just see the 2 figures, you can easily understand what's the main idea of it. Means, like you can see here, 2 and 5 is 1 cluster, and a more larger cycle, here's 1 cluster. Like here, in the floor, there's just different datas, but go 1 step, these 2, they are more close, so should be in 1 cluster, 1 cluster. So a more big value, more big level, these 2 will be 1 cluster. And that means 2 ways we can explain. So actually this kind of clustering will be in 2 types. One is start from point as individual clusters, means like here. One way is from this side, means we can take each state as a cluster, then go into, finally we get 1 big cluster. Another way is from, we take all the data as a big cluster, then we go into separated, means going 1 step, this 5 will be 1 cluster, this 1 will be 1 cluster, like this way. Means from bottom to root, and from root to bottom. Yeah, these 2 ways. And here I will just introduce 1 way, because similar way we can do for another case. And here is mainly algorithm for the means from bottom to the top we can use. First, so if you see the algorithm, you can easily understand that first we take every date as a cluster. You can see here for I belong to the date, and every date will be a cluster. Then this means the distance between the each 2 datas, and find the closest pair of cluster, means closest date, because date in the every data is a cluster in the first step. So then those 2 closest date will be one cluster. Means these 2 closest clusters will be 1 cluster. Then finally the clustering will be like divide these 2. Already we compile these 2. That's why we have to, from original clustering, we have to divide these 2 and add this one, new one. So repeated by this way, finally we can get all are in same cluster. So
One question.
yeah.
The clustering 해서
So here we introduce distance matrix. So for 2 point, easily we can say the distance just the real distance between them. But for if the one cluster with many data and another cluster with many data, so how to compute the distance from 2 clusters with many data? So there's several ways to consider. So means how to define the distance between 2 clusters. So here's several ways, and the first is a single link. Yeah. Single link means minimum distance between a point from or between 2 points from different clusters. Means we just find the minimum distance from these two, like 2 cycles. Just find the minimum distance. This is a single link. And one example is here. So here is the original date, and here means the date, the distance from each point. So here, A and B, just one distance. So, and here also one. But first, we can consider which will be going to combine first. So here we assume that A, B will be combined first. So here, so A, B will be combined. Then these two will be combined to a new cluster. And also for next, C, D will be combined to a new cluster. Then it will be going to see here. So, means going to here. Finally, we have this one, this one, this one, right? So here, so AB to CD is 2. But CD to E is 3. So we first to combine AB and CD to one cluster. Finally, just 2 cluster. Finally, just 2 clusters. So we again combine to one cluster. This is a very simple examples because we just choose the minimum distance. And here's another kind of distance defined just maximum distance, means also very similar things. And here's average, group average, not like the center, not like just the distance between center. Yeah, means we first consider all every vertex here and every vertex here to combine to take the summation of the distance, then divide it by number of the cluster in this set, and also number of cluster in this set. Yeah. Then we get this value. If this value is this, yeah. And also here, just to consider the center point, which the distance means we consider the minimum distance between the center point. Here's another kind of distance, but more complicated. So, after means because for first step we have the CI and CG, these 2 clusters combined to a new cluster CIG. So this new one, how to combine the distance this one to another CR? Because this is already new one. So here gives the rules of the how to combine the distance between this new one to others. So this is rules related to the distance CI and CG. Right? Here, if you use each method, then the alpha I, alpha G, beta, gamma will be given by this way. And here we are going to show the how means this two or this four method works from this example. Here. So for first step, these two methods are same. Second step are same. Next step, here different because this we are consider the minimum distance between them. Here means these two are minimum, but this one and this one more big, more larger distance, and this one also more larger distance. That's why we combine just this one. Here also some difference because this one will be more close to this cluster. And then finally, yeah, like this. So another example, there's some cities in America. It means here means the distance is long. If the like a real position in the map like this way. So here we are considered to taking the cluster by, as before introduced, several rules. First, these two we are taking single. Single means that the minimum distance. Then we have this graph, and if we take the maximum distance, we have this graph. Surely it already changed somewhere. And if we take average, and also word method means also difference comes. And also you can show how it works. Here we got the date from this package. Not here. Okay. Oh, here I just take this two method. That's why two graphs comes. Okay. So also that means which way we choose also will be different output will comes. So, but we have to get idea which kind of things we want to make cluster. So for this method, also some problems and limitations. First is once decision is made to combine two clusters, it can be not undone. Means if you combine by mistake, you combine these two clusters, but it's not easy to go the next step to the prepare step. And also it's different difficult to handling the different size clusters and convex shapes. And use of different distance metrics also will be different kind of results will come. So also for choosing the distance also is a problem. And the next is more very simple clusters, density-based clusters. For densities, first density is a number of points within special radius. Radius we denote by EPS. And a point is a core point if it has more than a special number of points or specified point of means this is given. Means if in one cycle the point is more than this value, then we call that point is a core point. A border point has fewer than this one, but inside this one. But in his neighborhood of core point. And north point is either this one or this one. So we are going to explain one example. So if we took mini point is 6, that means here we just talking about x, y, z. So in x, the cycle is like that. So here how many? 6. So it should be core point, right? So for y, just 1, 2, 3, 4, 5. So it should be not core point, but he's in the cycle of the core point cycle. So it should be border point. But this one also less the point in this cycle is less than 6, but it's not the neighborhood of any cycle in here. So it will be north point. So mainly idea of the density-based clustering algorithm is to divide data to core point and north point and the border point. Here maybe a little bit complicated, so I don't want to go inside. Actually, here's original point. If you choose a radio as 10 and the minimum point is 4. So we can get finally these graphs figures, and for green one is core point, and the blue one is border point, and the red one is noise point. So here by the color we can easily separate cluster the original data. And also here's another examples. Easily this one cluster. And those are core point.
So you have 4 moments.
Yeah. And also here's another examples, but with different radius and the minimal point. So also the results will become different, but this one will be more suitable. And here also the limitations means also for choosing the radius and minimum points, these two values is also very important. And also if the data with a large difference in density, then also it's difficult to use this method. And also depends on which distance measures we use. And finally, we are going to the conclusion part. And clustering has long history and still activity. And
It's not, you just spell check.
yeah. And we are. And also there's many set of new algorithms are developed every day, and because and also apply in many other areas, but the clustering is very hard to evaluate, but it's very useful to using it to get some use it to other areas, like to how to clusters. And final one is here's highly application dependent and to some extent subjectives. Yeah. And here some references is I mentioned before. Yeah. Okay.
Okay, Rakaba, would you summarize what shall we talked? Okay, Rakaba summarize what he did.